Yes, welcome. So the topic we'll be discussing in this lecture is A-star algorithm. So basically we are discussing about heuristic search techniques. So in the last class we have discussed the very basic version of heuristic search technique, which is greedy best first search. So this is A-star algorithm. It is a little improved technique. So here, so any heuristic search heuristic search algorithm, it will be using two functions as we have discussed in the last class. It will be using an evaluation function, and also it will be uh, uh, and also it will be using a heuristic function. This heuristic function will be a part of this evaluation function. This evaluation function will be represented as f of n. The evaluation function that is used in greedy best first search is f of n is equal to h of n. That is, just it uses h of n itself as the evaluation function. It uses the heuristic function itself as the evaluation function. But that is not the case with A-star algorithm. It uses a different evaluation function. It uses the evaluation function of this form: f of n is equal to g of n plus h of n, where h of n is the estimated cost. H of n is the estimated cost uh, from the current state to the goal state. So h of n is the heuristic component, the estimated cost from the current state to the goal state. And g of n is the actual cost from the initial state to the current state. So when you combine these two things, f of n is the estimated cheapest cost path from the initial state to the goal state, right? Uh, h of n is the estimated cost from the current state to the goal state. G of n is the actual cost from the initial state to the current state. So f of n is the estimated cheapest cost path. It's estimation, estimated cheapest cost path from the initial state to the goal state. So if you ask whether A star is optimal or not, optimal and complete, A star is optimal and complete under certain conditions. First, let us discuss the algorithm. Then we'll be discuss its conditions on completeness and optimality. So we'll be using the same map what we have discussed, the map of Romania, and here we'll be discussing like reaching from Arad to Bucharest. So our source will be Arad. The starting location will be Arad. So basically, we'll be seeing like how to reach from Arad to Bucharest. So that's what we are going to see. So this is our starting position. That is the initial state, and this will be the Bucharest will be the goal state. Okay. So when you apply A-star algorithm, what A-star algorithm does in the sense, see, h of n is the estimated cost. So our evaluation function is f of n is equal to g of n plus h of n, where g of n is the actual cost. So I'll call it as AP or AC, actual cost from initial state to current state, and h of n is the estimated cost, EC, from current state to goal state. So actual cost, somehow we know the actual cost because we are traversing the graph and we get the actual cost. But how do we get the estimated cost? So for estimated cost, we have to make some estimations or calculation. That is our assumption. But for these problems, we are assuming the estimated cost as the straight line distance. So which is given as per this table, as we have discussed in the last class. So the same h of n will be using the straight line distance from every city to Bucharest. So basically this table shows the straight line path from every city to Bucharest. So with this input, let us proceed. So our starting position is Arad. So let us see here from Arad to Bucharest, the cost is 366. So here, how can we represent now? Now, initially we are in the initial state. So how can we apply on this function? So what is our g of n at this point? When the agent is in Arad, what is g of n? G of n is the actual cost from the initial state to the current state. Now, initial state and current state both are same. At this point, initial state is equal to current state. So what is the actual cost of reaching from initial state to the initial state? That is, current state is also initial state. So what is the cost of reaching from Arad to Arad? It is 0. So g of n is 0. And what is h of n? H of n is the estimated cost of reaching from Arad to Bucharest. So for that we have to refer this table. So what is the, so because we are using this as the heuristic function. So what is the estimated cost of reaching from Arad to Bucharest? That is 366. So what we get is 0 plus 366. That is g of n is 0, h of n is 366. So we got 0 plus 366, which is 366. So at Arad, this is what our status. Now from Arad, what are the options we have? The agent, where the agent can move from Arad. From Arad, the agent can move to Timisoara at the cost of 118, or it can move to Sibiu at the cost of 140, or it can move to Zerid at the cost of 75. So, so how can we represent that? So basically, better I will open a what you call canvas for drawing. It will be easier. Okay, so currently, initially we are in Arad. So we are in Arad, and at this time, what is our h of n? And I mean, what is our? It is 366, which how we got this 366? It is 0 plus 366, because g of n is 0 and h of n is 366. Okay. From Arad, where we can move? We can move to Timisoara, Sibiu, and Varadia. So, how can I represent that? So this is Arad. From Arad, we can move to Timisoara. We can move to Sibiu and Varadia. Okay. So this is Timisoara. This is Sibiu. This is Varadia. I'm writing some short names. Okay. So what is the cost of reaching to Timisoara? The cost of reaching to Timisoara is 118. Sibiu 140. Not Oradia, Zerind. Arad to Zerind. Okay, there is no direct path to Oradia. Zerind 75. So 118, 140, and 75. So this is it can reach Timisoara at the cost of 118. It can reach Sibiu at the cost of what is that? At the cost of 140, and it can reach Zerind at the cost of 75. Okay. So this is 140, and this is 75. So this is Zerind. So this is Zerind, right? Now what all these things are now? Now what is now 118 is nothing but the actual cost of reaching from Arad to Timisoara. 140 is the actual cost of reaching from Arad to Sibiu. This 75 is the actual cost of reaching from Arad to Zerind. Now for all these things, let us calculate the f of n. So this is g of n for Timisoara. And what is the h of n for Timisoara? That is what is the estimated cost of reaching from Timisoara to Bucharest. So it is 329. Okay, so it is 329. So 118 plus 329. So that will be the f of n value. And for CPU, what is, so this is g of n, and what is the h of n for CPU? That is what is the estimated cost of reaching Bucharest from CPU? It is 253. So this is 140 plus 253. And what is the estimated cost of reaching? This is the g of n for Zerin, and what is the h of n for Zerin? That is the estimated cost of reaching from Zerin to Bucharest. So it is 374. So plus 374. So when you add this 118 plus 329, what you get? 118 plus 329, it is 447. This is 447. Okay. Then what is the cost of this? 140 plus 253. 140 plus 253, it is 393. It is 393. And what's the cost of this? 75 plus 374. 75 plus 374. It is 449. So this is 449. Okay. So now this algorithm, what it will choose in the sense, Dijkstra algorithm from, so it has three paths to explore. Now the question is which path it will explore. It will explore the cheapest cost path. So out of this, which is the cheapest cost path? Which cost promises the cheapest cost? These are now estimated cost only. Estimated cost of reaching from the initial state to goal state. So the estimated cost of reaching via Timisoara is 447. Via CPU is 393. Via Zerin this 449. So algorithm will explore CPU. Okay. So the algorithm will explore CPU. So after this, it is going to explore CPU. So you can see here it is exploring CPU. In this diagram, they are mentioning CPU at first, but it can come in any order. Okay. So that's the point. So the algorithm is going to explore CPU. So now let us see the map. From CPU, what are the paths we have? From CPU, you can go to Ruminseville CA, you can go to Fagares, you can go to Arad, or you can go to Varadia. So there are four possibilities we have. What are they? Ruminseville CA at the cost of 80. You can go to Fagares at the cost of 99. Again, you can go back to Arad, but that also we should include at the cost of 140. And you can go to Varadia at the cost of 151. Right? 80, 99, 140, and 151. So that is the path we are going to explore next. So from CPU, so this I will write here. Just we got here 393. How we got this 393? This is nothing but 140 plus 253. So with that we got that 393, and that is the cheapest cost so far available. So we are going to explore CPU further. So when you explore CPU further, there are three possibilities we have. What are the three possibilities? Sorry, four possibilities we have. You can reach Ruminseville CA at the cost of 80, and you can reach Fagares at the cost of 99. It is 99, and you can reach Arad back at the cost of 140, and you can reach Varadia at the cost of 151. Okay. So now for all these things, we should calculate the what you call the evaluation function f of n. So we know it is 80. So what is the, the h of n? It is 80 plus. That is from Ruminsu-Vilsier. What is the cost of reaching to? I mean, what is the estimated cost of reaching to Bucharest? It is 193. Okay. So it is 80 plus 193 here. And from Fagares, what is the estimated cost of reaching to Bucharest? From Fagares, what is the estimated cost of reaching? Where is Fagares? Yeah, 176. It is 176. So it is 99 plus 176. Okay. And from Arad, what is the estimated cost? So Arad estimated cost is 366. Here we have, right? It is 366. Okay. So, so it is 140 plus 366. So it is 140. I'll write here 140 plus 366. And Oradia, from Oradia, what is the cost? 380. Estimated cost of, that is h of n is 380. So it is 151 plus 380. Now we have to add all these things. What is 151 plus 380? So 380 plus 151, it is 531. So this is 531. And what is 140 plus 360? 140 plus 360, it is 500. So this path is 500. And this is 99 plus 176, that is 275. This is 275, the the respective f of n value. And what is this? 193 plus 80, that is 293, 283, 273. So this is 273, right? So this path is 273. Here we got 273. Fine. So now what the algorithm should do in the sense, out of all the unexplored path, what is the minimum it should see? Not only these nodes, out of all the unexplored nodes, it should find the minimum. So what are the unexplored node? This is also an unexplored node. What is this? 447. This is also unexplored. What is this cost? 449. Oradia, what is the cost? 531. This is 500. This is 275. This is 273. So we are going to take the path of Ruminsu-Vilsier, RV, right? So out of all the unexplored nodes, you have to take the minimum path node. So that you have to be careful here. It's not only these nodes. From all the unexplored nodes, we have to find the minimum. So you can see here from CBU, what it is exploring. From CBU, oh, Fagares is having less value as per this. Let me check. What is the path of Fagares? Fagares is the cost of reaching to Fagares from CBU. What's the actual cost of reaching from CBU to Fagares? Let us check. Oh, CBU to Fagares is 80. Is it? Okay. CBU to Fagares is 99. CBU to Fagares is 99. And what's the estimated cost of reaching from Fagares to Fagares? 176. Okay, I think I'm seeing the wrong algorithm. Yeah. This is greedy best first search. I'm sorry. Okay, this is our algorithm, right? So from CBU, we are going to explore this Ruminsu-Vilsier because this is the one with the least cost. Okay, so yeah, so what's the cost? Yeah, but again, our cost seems to be different. Why? Yeah, I think we have missed this previous cost. Yes, something we missed. Mm, 275. I'm sorry. Yes. See, what is the cost of reaching from Arad to CPU? It is 140. This 140 should be added to all these things. Okay. So that 140 actually I'm missing here. Okay. Because it is a cumulative cost. Okay. So when you add 140 to all these things, so okay, so at what cost you reach? I mean, we are reaching Arad to CPU at the cost of 140, right? So that also should be added to this. So when you add 140 to Rumin Civil CA, what you will get? 273 plus 140, 273 plus 140, that is 413. Okay. So, 413. So that is how here you got 413, right? So yeah, that should be added because we cannot ignore that, because how we are reaching here, we are via this path only we are reaching, right? So this is the, so what is this? This is the actual cost of reaching from the current initial state to the current state. It is not only from the previous state to the current state. Okay. So it is initial state to the current state. So when you say initial state to the current state, it is what? It is what? So I'll write here clearly. So the cost of reaching to Ruminsu will CA is 140 plus 80. Okay. So that is the, so 80 is the cost of reaching from CPU to here. 140 is the cost of reaching from Arad to here. So this is the actual cost plus 193, and as a result we got 413. Similarly, if you take this path via Figueres, it will be 140 plus 99, right? It will be 140 plus 99. This is the actual cost plus 176. Okay. Similarly, via Arad, it will be 140 plus 140, 140 plus 140 plus 366. Okay. And via Varadia, it will be 151 plus 140 plus 380. So to everything we should add at 140. So when you add 140 with this, you get 413. And when you add 140 with this, okay, this is 275 plus 140, right? That is 375, 375, then 400, right? 400 plus 15, I think this is 415. This is 500 plus 140, this is 640. 531 plus 140. Okay. 530 plus 140 is 630, 670, 671 plus 140, 671. Okay. Right. So now I think we can check 413, 415, 640, 617. 413, 415, 646, 671. Okay. Yeah. So that's how we got these values. Okay. But again, you have to see out of all these things, which is the smallest one out of all the unexplored nodes. So this is 414, this is 447, this is 413, 415, 640, and this is 449. Out of all the unexplored nodes, now also if you see this Rumin Civil CA is the cheapest cost path. Okay. So we should further explore this one. Okay. So we should explore this. So what are the nodes you can reach from means RV? So from RV, you can go to Pitesti, you can go to Craiovia, and you can go to CBU. Okay. So you can go to Craiovia at the cost of 146, right? But we should add the cumulative cost, that we should not forget. And we can reach Pitesti at the cost of 97, and we can reach CBU back at the cost of 80. Okay, so let me draw that. So from RV you can reach what? We can reach to Craiovia, at the cost of 146. But what is already the actual cost of reaching to RV? The actual cost of reaching to RV is already, it is 140 plus 80. So to that again we have to add plus 146. So what is that? So 140 plus 80 plus 146. So this will be 140 plus 80 plus 146. I think 140 plus 80 plus 146, which is 366. 140 plus 80 plus 146 is 366, right? Okay, so it's 140 plus 80 plus 146, right? So it is 366. This is the actual cost. This is G of n, right? But okay, similarly let us first calculate the G of n for all, and the next destination it can reach is, it can reach Petoskey. It can reach Petoskey at the cost of 97. So 97. So that means what? So that means instead of 146 here we have to add 97. So what is that? 140 plus 80 plus 97. So it is 140 plus 80 plus 97. So it is 317. So for reaching Petoskey, the actual cost is 317 via RV. Okay. So there is another path. What is that? From RV, you can reach to CBU. So what's the cost of reaching to CBU? So it is 80. So it is 140 plus 80 plus 80, right? So it is 140. Basically, it is 140 plus 160, right? So I guess it is 300, right? It is 300, right? Okay. Now, what is the uh, heuristic cost of reaching from Craiovia to the uh, destination, that is Bucharest? So for that we have to refer this table. So from Craiovia, what is the 160? The heuristic cost is 160. Okay. So to this we have to add 160. To this we have to add 160. Similarly to this Petoskey, from Petoskey, what is the actual cost? From Petoskey, the actual cost is 100. So to this we have to add 100. And from CBU, what is the actual cost? I mean heuristic cost. All these are heuristic cost. 253. Okay. So to this we have to add 253, right? 253. So what we get? So 366 plus 160. So this is 366 plus 160. 366. Sorry. 366 plus 160, which is 526. So this path is 526. This is 317 plus 100, which is 417. Okay, this is 417. Next, this is 300 plus 253. What is that? That is 553. 553, right? Okay. So let us check whether we are traveling in the correct direction or not. So what we got at last, these are the values: 526, 417, and 553. So as per this, yeah, 526, 417, 553. Okay. So this graph is, so whatever I have drawn here, it is same as this, but this is much better. Okay. So we can see this. Now from all these unexplored node, you have to identify the minimum mode. So that part you should be very careful. So when you see from all the unexplored nodes, see this is 646, 415, 671, 526, 417, 553, 447, 449. So which is minimum? This is minimum. Fagorus is minimum, not Pitesti. See, Pitesti is 471. This is Fagorus 415. In the previous round, what we got. So this node we should explore now. Okay. So in our graph also here, if you see Fagorus here, you can see it is 415. So this is what we are going to explore. Because out of all the unexplored node, now this is the minimum cost one. Okay. So now we'll explore Fagorus, right? So now when you explore Fagorus, so better I will continue here because this is much clear. It is of much clear. Okay. So from Fagorus, we have what are the destinations we can reach. So that is what we have to check. So so where is Fagorus? Here. From Fagorus, there are only two paths. You can reach either Bucharest or you can reach Sibiu. Okay. From Fagorus, you can reach Bucharest or you can reach Sibiu. Okay. So what is the cost of reaching Bucharest? Bucharest can be reached at the cost of 211 and Sibiu can be reached at the cost of 99. Okay. So, right. But already what is the actual cost of reaching to Fagorus? The actual cost of reaching to Fagorus is 239. So it can reach Bucharest. It can reach Bucharest at the cost of 211. So, but already the cost of the actual cost of reaching up to Fagorus is 239. So 239 plus 211 we should add. Okay. So what is that? 239 plus 211. 339, 439, 449, 450, right? 450. So this is the actual cost of reaching from Sibiu to Bucharest, right? 450 plus we have to add the heuristic function, but let us wait for that. Now what is the another destination we can reach? We can reach Sibiu. Again, if up to reaching Fagorus is 239, and what is the cost of reaching from Fagorus to Sibiu? It is 99. So 239 plus 99 is 339, 338. So it is 338 plus the heuristic cost of reaching from Sibiu to the goal state. Okay. Now Bucharest is actually the goal state. So what is the cost of reaching from Bucharest to Bucharest? It is 0, right? From Bucharest to Bucharest, it is 0. So it is 450 plus 0. And Sibiu to Bucharest, for that we have to refer the table. So what's the cost of reaching from Sibiu to Bucharest? It is 253. Sibiu to Bucharest is 253. So it is 338 plus 253, right? Okay. So it is 338 plus 253. Now, now you can add this. 450 plus 0 is 450. 338 plus 253 is what? 338 plus 253 is 338 plus 253, which is 591. Okay. So it is 591. Okay. So now, so actually the algorithm does not stop it. Even though we have found a goal state, the algorithm is not going to stop. Okay, because this algorithm that I think it works in this way. That is, the goal test will be done during expansion. Okay, so the goal test will be done during the node expansion, right? Not during node generation. Now Bucharest is generated; it's not yet expanded. So while expanding only, the goal test will be done. Okay. So fine. Now from the unexplored node, again we should see which is the minimum cost one. Which is the minimum cost one. So now this is 450, this is 591, 646, this is 671, this is 526, this is 417, 553, 447, 449. Now minimum cost is Pitesti. This is the minimum cost one. Now we have to explore Pitesti. So this is the minimum cost one. Now we have to explore Pitesti. From Pitesti, what are the things you can reach? From Pitesti, what are the destinations we can reach? let us see the graph. From Pitești, you can reach Bucharest, you can reach Craiova, and you can reach Ruminci-Vilșie. So what is the cost? What's the cost? From Pitești, we can reach Bucharest at the cost of 101. Okay, and we can reach Craiova at the cost of 138, and we can reach Ruminci-Vilșie at the cost of 97. Okay, so that will add to the graph. Okay, so from Pitești you can reach Bucharest, right? The cost is 101, but already what is the actual cost of reaching to Pitești? 317. So you have to add that. The actual cost of reaching to Pitești from Arad, from the initial state, is 317. So we are 317 plus 101. So what is 317 plus 101? 418. So it is 418 plus h of n. Okay. Then what's the cost of reaching from Pitești to Craiova? It is 138, but already what is the cost of reaching to Pitești? It is 317. Okay. So 317 plus 138. 317 plus 138. So that we have to add 317 plus 138, which is 455. So this is 455 plus something. Okay. And similarly from Pitești, you can also reach Ruminci-Vilșie. So what's the cost of reaching from Pitești to Ruminci-Vilșie? It is 97. And the cost of reaching from up to Pitești is 317. So 317 plus 97 is 414, right? 417 minus 3, 414. Yeah, 414. Okay, plus the heuristic cost. So what is the heuristic cost of reaching from Bucharest to Bucharest? It is 0. So this is 418. And what is the heuristic cost of reaching from Craiova to Bucharest? So we have to refer the table again. So Craiova to Bucharest, it is 160. Okay, and Ruminci-Vilșie to Bucharest, it is 193. Okay, so it is. So what we got here, this is plus 160, and this is plus 193. So this is this evaluation function. This for Bucharest, what we got is 418, and here 455 plus 160. What is that? 455 plus 160, which is 615. Okay, so this is 615, right? And this is 414 plus 93. 414 plus 93. 414 plus 193. Yeah, plus 193, which is 607. Okay, so this is 607. Now from all the unexplored node, you see which is the minimum cost. This is 646, 591, 451, 450, 526. This is explored 553, 447, 449, 418, 615, 607. Minimum cost is this one, 418. So now this should be explored. Now Bucharest should be explored. Before exploring, it will check whether this is a goal state or not. Yes, this is a goal state, so the algorithm will stop here. Okay. So A-star algorithm will check for the goal state during expansion, not during generation. Then only it will find the optimal path. This is the optimal path. This is not the optimal path. Okay, because this cost, you see, it is 450. But this cost was explored at first, whereas this cost is only 418. Okay. So this is how this algorithm works, and this is the last step. So what we got value here, it is correct, 418, 615, and 607, right? Okay. So this is the basic idea of A-star algorithm. So now the question whether A-star algorithm is optimal or not. A-star algorithm is optimal under two conditions. If h of n is admissible then A star algorithm is optimal. And if h of n is consistent, that is, if h of n is admissible and consistent, then A star is optimal. If the function h of n is admissible and consistent, then A star is optimal. What is admissible? An admissible heuristic function is one which never overestimates the cost to reach the goal state. So this is how we define the admissibility property of an heuristic function. A heuristic function is called as admissible if it will not overestimate the cost of reaching the goal state. It can underestimate, it should underestimate, but it should not overestimate. Okay, because if it overestimate, then it cannot find the optimal path. Say for example, say this is you are currently in this state A. Say you want to reach the state B. Okay, um, say before B there is a state called uh, A1, and here there is another state A2. After B there is a state called B1 and B2. Right now, what the algorithm says, this is the initial state, this is the goal state. The heuristic function, what it the admissibility property of the heuristic function, what it says in the sense, it can underestimate, but it should not overestimate. So let us assume the actual distance of reaching from A to B is, let us say it is 10 kilometers. Okay. Now this the heuristic function can underestimate to any degree, but it should not overestimate. Why? The reason is, assume the heuristic function assumes that the cost of reaching the goal state is only 3 kilometers. Then it will travel up to 3 kilometers and it will check is this is goal state or not. It has reached a state A1. No, it's not goal state. Okay. Now the remaining distance is what? 7. Out of this remaining 7, it should underestimate. It should not overestimate. So next also it assumes that the heuristic function assumes that the destination is at 3 kilometers. So it reaches A2. Now it checks whether this is the goal state. No. The algorithm checks whether this is the goal state. No. Now what's the remaining distance? Only 4 kilometers. Out of this 4, now it should underestimate. So it may say it estimates as 2 kilometers. So it reaches some other midpoint. It checks whether this is the destination. No. Okay. Now the actual gap is only 2 kilometers, but still it should underestimate. So say it estimates that the heuristic function estimates that the destination is in 1 kilometer. Now it goes up to 1 kilometer and checks whether this is the goal state. No. Now the actual distance is 1 kilometer. Now also it should underestimate. Now it may assume it is only 800 meters. After going 800 meters, it will check whether it's the goal state. No. Then the remaining distance is 200 meter. Now also it should underestimate. Now it should go 100 meter and it should check whether this is the goal state. No. Now the remaining 100 meter. Now it should go another 50 meter, 40 meter. Like that it should go. Then only it will get the optimal solution. So at one point, the distance will be only 10 meters. Then it will reduce. Then the heuristic function should estimate it as 5. Then it should estimate it as 2. Then it should be estimated as 1. So like that, if it goes only, it will find the optimal solution. Suppose if it overestimates, what will happen? Say from the initial state, actual distance is 10 kilometers. Okay. Say it overestimates. Say it overestimates and it has reached to this state B2. Okay. It checks whether this is the goal state or not. No, it's not a goal state. But let us assume that the same goal state is available here also at a distance of 15 kilometers. Now from B2, it may travel and find this as the goal, and the algorithm may say that I have already find the goal. Okay, the algorithm has find the goal, it has find the solution, but it is not an optimal solution. So this is the reason the heuristic function should underestimate the goal state. It should never overestimate. Okay, such a heuristic function is called as admissible heuristic function. So if h of n is admissible, that is one of the property, that is one of the requirement for A star to be optimal, right? Okay, so so h of n must be admissible. That is, it should never overestimate the cost of reaching the goal state, right? And the second property is consistent. A heuristic function is consistent if it satisfies this property. What is this property? This property says that h of n should be less than or equal to c of n comma a comma n dash plus h of n dash. Okay. So what is this? H of n is the heuristic cost of reaching to the goal state from the nth state. So current state is n. So it is the estimated cost of reaching to the goal state from state n. So the estimated cost of reaching to goal state from n. Okay. Whereas what is h of n dash? It is the estimated cost of reaching to goal. It is the estimate of reaching to goal state from, sorry, I'll write in some. So h of n dash is nothing but it is the estimated cost of estimated cost of reaching to goal state from n dash. So that's the only difference. But what is n dash? So h of n is the cost of reaching to goal state from the state n, and h of n dash is the estimated cost of reaching to the goal state from n dash. But what is n dash? N dash is a successor of n. Okay. So n dash, so there is a node n or there is a state n. And what is n dash? N dash is a successor of n. And you can move from n to n dash by performing an operation A. You can move from the state to, the agent can move from the state to n, from the state n to n dash by performing an operation or an action A. So that is what it says. The c of n comma a comma n dash means the cost of moving from n to n dash by performing the action A. Okay, c represents cost, right? So when you perform a operation A in n, you will move on to n dash. Okay, but there is a cost involved, that is different. But there is a cost involved in doing so. So that cost is this c of n comma n dash. So this is actually the actual cost. This is actual cost. This cost is actual cost. But this h of n dash is the heuristic cost. H of n dash is what? It is the heuristic cost, the estimate of reaching to the goal state. So that is h of n dash. What is h of n? There is another thing, h of n. What is h of n? The estimated cost of reaching from n to g of from the state n to the goal state. Now this equation, what it says in the sense, this h of n value, okay, this h of n value should be less than or equal to this cost. This is actual cost. This is actual cost, okay, plus h of n dash. If it satisfies this condition, then it is a consistent heuristic. Okay, because this is actual cost. So when you add this actual cost with this h of n dash, then this value should be less than that. It should not become greater than that or equal. It can be less than or equal to, but it should not become greater than. Then h of n is called as consistent. Okay, right? So in that case, we say h of n is consistent. And if every consistent heuristic is also admissible. If the heuristic is consistent, it is admissible. Because admissibility is a subset of consistency. Because what is h of n? Because what is admissible? Admissible says that it should not overestimate. Okay, it should not overestimate from the current state. So when it is consistent, obviously it is admissible, right? Fine. So let us stop here for today's session, and we'll continue the rest in the next session. Okay. So thank you.